Right now, as you listen to this, an ancient wanderer is passing through our solar system. Billions of years of travel across the emptiness between stars brought it here, and once it leaves, it will never return. Its name is 3I, Atlas, and no object from beyond our solar system has ever moved faster through our celestial neighborhood. But here's what captured the world's attention. Every 16 hours, this interstellar visitor pulses with light, a rhythmic brightening, a pattern. And when Harvard astrophysicist Avi Loeb suggested it might not be entirely natural, the internet erupted with speculation. Headlines screamed about alien spacecraft, social media filled with theories, and millions of people asked the same question about whether we should be worried. Tonight, we're going to answer that question definitively by examining every piece of verified evidence, every official statement from NASA and ESA, and every measurement from the Hubble and James Webb Space Telescopes. By the end of this journey, you'll understand not just whether 3I Atlas poses any danger to Earth, but what this object truly is, where it came from, and why scientists call it the most significant interstellar visitor we've ever had the privilege to study. If you find yourself returning to this channel, if these quiet explorations help you drift into sleep or simply give you something meaningful to contemplate, I'd be grateful if you'd consider subscribing. Your support helps this channel continue, and it means we can keep making these deep dives into the mysteries that matter. From the outset, the evidence shows something clear. NASA's Center for Near-Earth Object Studies determined immediately after discovery that 3I Atlas poses no impact hazard whatsoever, and the European Space Agency's Planetary Defense Office confirmed this assessment independently. At its closest approach to Earth, on the 19th of December 2025, this interstellar comet will remain approximately 270 million kilometers away from our planet. That distance translates to 1.8 astronomical units, nearly twice the distance from Earth to the Sun. Here's what that means in practical terms. NASA defines a potentially hazardous object as anything passing within 0.05 astronomical units of Earth's orbit. At 1.8 AU, 3I Atlas stays 36 times beyond that threshold, passing approximately 700 times the distance from Earth to the Moon. And during its closest approach, our planet will sit on the opposite side of the Sun. No danger exists. No danger ever existed. The trajectory was certain from the first reliable observations. But the absence of threat doesn't diminish what's happening here. It's precisely because 3I Atlas poses no danger that we have this extraordinary opportunity to study it, to gather data about an object that may predate our entire solar system, that carries within its ancient ice the chemical fingerprints of a stellar nursery we will never visit, that offers us a window into conditions that existed before our sun was born. This is the story of that opportunity, and it begins with a telescope in Chile scanning the night sky for objects that don't belong. The 1st of July 2025 brought a faint point of light moving against the background stars. Detected by the Atlas telescope system, the Asteroid Terrestrial Impact Last Alert System. The initial designation was forgettable, just A11PL3Z, another object among thousands cataloged every night by automated survey systems scanning for potentially hazardous asteroids. Within 24 hours, something unusual became apparent. The object's trajectory didn't fit, and when astronomers calculated its orbit, they found an eccentricity of 6.139, far higher than any object bound to our sun could possess. For reference, a circular orbit has an eccentricity of 0. Earth's slightly elliptical orbit sits at about 0.017, and anything above 1 means the object follows a hyperbolic path moving too fast for the sun's gravity to capture it. At 6.139, this object wasn't just passing through, it was screaming through our solar system at velocities that made its origin unmistakable. On July 2, the Minor Planet Center made it official with a designation 3I Atlas, where the 3I indicates this was the third confirmed interstellar object ever detected, following 1I, Oumuamua in 2017, and 2I, Borisov in 2019. Atlas credited the survey system that found it, and that's when the story becomes more interesting. While Atlas gets credit for the discovery, astronomers quickly realized they had been looking at this object for months without recognizing what it was. Pre-discovery observations revealed that NASA's test satellite, the Transiting Exoplanet Survey Satellite, had detected cometary activity from this object as early as the 7th of May 2025, nearly 2 months before the official discovery. Between May 22 and June 21, the Zwicky Transient Facility recorded it multiple times. The object had been hiding in plain sight, its true nature obscured by the sheer volume of data these surveys generate every night. On that same day, July 2, astronomers David Jewett of UCLA and Jane Liu used the Nordic Optical Telescope to take a closer look. What they saw removed any doubt about what they were dealing with. The object was, in their words, clearly active, displaying a diffuse appearance characteristic of cometary outgassing. This wasn't a dead rock tumbling through space like Oumuamua had appeared to be. This was a comet actively releasing gas and dust as it approached the warmth of our Sunday. Confirming cometary activity mattered for several reasons. It meant we could study the object's composition by analyzing the light from its coma, the envelope of gas surrounding the nucleus. It meant the object was substantial enough to have retained volatile ices despite billions of years of cosmic ray bombardment in interstellar space. And it meant we had time. Unlike Oumuamua, which was already on its way out of the solar system when discovered, 3I, Atlas, was still inbound, giving astronomers weeks to prepare their observations before its closest approach to the Sunday. The evidence for interstellar origin deserves attention, because understanding why astronomers are so certain tells us something about how we detect these visitors in the first place. Every object in our solar system, every planet, every asteroid, every comet from the Kuiper Belt or the Oort cloud remains gravitationally bound to the Sunday. Their orbits, no matter how elongated, eventually bring them back. Thousands of years might pass before a single orbit completes, but orbit they do. The mathematical signature of a bound orbit is an eccentricity less than 1. 3I, Atlas enters our solar system with a hyperbolic excess velocity of 58 kilometers per second, the speed it will have relative to the sun even after accounting for the sun's gravitational acceleration. That's the speed it brought from interstellar space. And at 58 kilometers per second, it travels nearly twice as fast as Oumuamua did when that object passed through in 2017. This velocity tells us something profound. Our sun cannot capture this object. No gravitational interaction with any planet in our solar system will slow it down enough to change that fact. 3I, Atlas, is passing through, and it will exit our solar system and continue into the void between stars, never to return. Consider what that means for a moment. This object has traveled through interstellar space for billions of years. It has never orbited our sun before, and it will never orbit our Sunday. This is a one-time encounter, a brief intersection of trajectories that allows us a fleeting glimpse of material from another stellar system entirely. Current size estimates for 3I Atlas come from Hubble Space Telescope observations, ranging quite widely from 320 meters to as much as 5.6 kilometers in diameter. This large uncertainty exists because the comet's nucleus is obscured by dust and gas in its coma. We're not seeing the solid body directly, but rather the cloud of material surrounding it, and we have to infer the nucleus size from how much gas and dust is being released. Most astronomers believe the nucleus is likely under 1 kilometer in diameter, similar in size to 2I, Borisov. But even a 1 kilometer object, when it's actively outgassing and producing a coma that extends for thousands of kilometers, creates quite a spectacle. Now for the mystery that captured so much public attention, the 16-hour brightness variations. Shortly after discovery, observers noticed that 3I, Atlas, wasn't maintaining a constant brightness, but instead pulsing, brightening and dimming with a period of approximately 16 hours. The variation measured significantly enough with moderate-sized telescopes, ranging from about 0.2 to 0.3 magnitudes, and the regularity of this pattern immediately sparked speculation. The explanation turns out to be straightforward, something any astronomer familiar with comets would recognize. The nucleus of 3I, Atlas, has an irregular shape, as most cometary nuclei do, and it rotates with a period of somewhere between 16.16 and 16.79 hours. As it rotates, different regions of the surface face sunlight. Some of these regions hold more volatile ices than others. When a volatile-rich region faces the sun, outgassing increases and the comet brightens. When that region rotates away, activity decreases and the comet dims. This matches exactly what we observe with comets from our own solar system. The nucleus of Comet 67P, Churyumov-Gerasimenko, famously visited by the Rosetta mission, displayed similar behavior with jets of gas erupting preferentially from certain areas of the surface, creating a rhythmic pattern tied to the comet's rotation. What's notable about 3I Atlas is that astronomers observed this brightness variation decreasing over time from about 0.3 magnitudes in early July to about 0.2 magnitudes later in the month. This makes sense. As the comet's activity increased and its coma grew more substantial, the glow of the coma began to wash out the variations from the rotating nucleus. The pattern was still there, but it was being masked by the increasingly bright envelope of gas surrounding the solid core. August 2025 brought the James Webb Space Telescope's infrared instruments to bear on 3.1 ATLAS. And what they revealed was remarkable. The JWST observations detected several key gases being released from the comet's nucleus. Carbon dioxide was being expelled at a rate of approximately 129 kilograms per second, water vapor at about 6.6 kilograms per second, carbon monoxide at approximately 14 kilograms per second, and atomic nickel at about 4.6 grams per second. That nickel finding came without the accompanying iron that typically appears alongside nickel in comets from our own solar system. That ratio of carbon dioxide to water, roughly 8:1, stands among the highest ever observed in any comet. Comets from our own solar system typically show water as the dominant volatile because water ice remains stable at the distances where most comets form and reside. Carbon dioxide, being more volatile, tends to appear in smaller quantities or gets depleted over time. The fact that 3I Atlas has so much carbon dioxide relative to water tells us where it formed. This object likely coalesced in a region far from its parent star, in the cold outer reaches where carbon dioxide ice could remain stable. It may have spent its entire existence in the deep freeze of interstellar space, never approaching another star closely enough to lose its volatile carbon dioxide to solar heating. Tom Statler, NASA's lead scientist for solar system small bodies, put it this way: we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system, which gives me goosebumps to think about, frankly, because that means 3I Atlas is not just a window into another solar system, It's a window into the deep past. Our sun is approximately 4.6 billion years old. Estimates for the age of 3I Atlas range from 7 to 14 billion years. This object may have been drifting through space since before our sun existed, carrying within its ancient ice a record of conditions in a stellar nursery that has long since dispersed, evidence of chemical processes that occurred when the universe itself was young. And now, briefly, it passes through our neighborhood, close enough to study, far enough to pose no threat, before continuing its endless journey into the darkness between stars. Here's where we stand so far. 3I Atlas holds the distinction of being the third confirmed interstellar object ever detected, discovered by the Atlas Telescope System on the 1st of July 2025. It travels at a hyperbolic excess velocity of 58 kilometers per second, nearly twice as fast as Oumuamua, with an orbital eccentricity of 6.139, the highest of any known interstellar object. This trajectory is unbound, meaning the comet will pass through our solar system once and never return. Somewhere between 320 meters and 5.6 kilometers describes the estimated nucleus diameter, though most estimates place it under 1 kilometer. The 16-hour brightness variations that spark so much speculation come from the nucleus's rotation, which periodically exposes different volatile rich regions to sunlight. JWST spectroscopy revealed an unusual composition dominated by carbon dioxide, with a CO2 to water ratio of approximately 8 to 1, among the highest ever observed. This suggests the object formed far from its parent star and may range between 7 and 14 billion years old. And most importantly, for our central question, NASA and ESA have confirmed that 3I Atlas poses absolutely no threat to Earth. At closest approach on the 19th of December 2025, it will remain 1.8 astronomical units, or 270 million kilometers from our planet, 36 times beyond the threshold defining potentially hazardous objects. Now let's examine that threat assessment in detail. Understanding why astronomers are so confident about the safety of 3I Atlas requires examining its trajectory through our solar system in detail. The comet entered our solar system from above the plane of the planets, following a hyperbolic path that brought it first past Mars, then toward the Sun, before curving outward toward Jupiter and eventually back into interstellar space. Let me walk through the key milestones. The 3rd of October 2025 marked the closest approach to Mars, with 3I Atlas passing at a distance of 0.19 astronomical units, approximately 29 million kilometers from the red planet. This was the closest the comet came to any planet in our solar system, and it occurred while multiple spacecraft were in Mars orbit, providing unprecedented observation opportunities from a vantage point impossible to achieve from Earth. The 29th of October 2025 brought perihelion, the closest approach to the Sun, at a distance of 1.36 astronomical units, roughly 203 million kilometers. This placed the comet just inside Mars's orbit, but still considerably farther from the Sun than Earth ever gets. The 3rd of November 2025 saw the closest pass to Venus at 0.65 astronomical units, about 97 million kilometers. The 19th of December 2025 marks the closest approach to Earth at 1.8 astronomical units, approximately 270 million kilometers. That's the figure that matters most for our question tonight. 1 astronomical unit equals the average distance from Earth to the Sun, about 150 million kilometers. At 1.8 AU, 3I divided by Atlas sits nearly twice as far from Earth as Earth sits from the Sunday. During its closest approach, our planet will be positioned on the opposite side of the Sun from the comet. For comparison, NASA defines a potentially hazardous asteroid as any asteroid coming within 0.05 AU of Earth's orbit. At 1.8 AU, 3I, Atlas remains 36 times beyond that threshold, passing at approximately 700 times the distance from Earth to the Moon. The Moon sits about 384,000 kilometers away. 3I, Atlas, will be 270 million kilometers away at closest approach. If you imagine the Earth-Moon distance as one step, 3I, Atlas, would be 700 steps away. No mechanism exists by which this object could threaten Earth. Its trajectory doesn't come anywhere near our planet. The calculations are certain, and the observations confirm the calculations. The official statements from space agencies have been remarkably clear and consistent, a stark contrast to the speculation that has swirled on social media. NASA's official frequently asked questions on 3I, Atlas addresses the question directly. Is there a danger of this interstellar object hitting Earth? No. Although the trajectory of 3I, Atlas, brought it just inside the orbit of Mars, it is now heading outbound from the Sun and won't come close to Earth at all. Kelly Fast, NASA's acting planetary defense officer, explained the assessment process. CNEOS used the position measurement data submitted to the MPC by ground-based observatories to determine it would not approach Earth and was not considered an impact hazard. CNEOS is NASA's Center for Near-Earth Object Studies, the organization responsible for tracking all objects that might pose a collision threat to Earth. The European Space Agency's Planetary Defense Office issued an equally definitive statement. The closest the comet will come to Earth is about 270 million km. That's about 1.8 times the distance between Earth and the Sun. It poses no danger to our planet or any other planets in the solar system. On the 19th of November 2025, NASA held a press briefing specifically to address public interest in 3I, Atlas, and to counter misinformation that had spread online. Associate Administrator Amit Kshatriya was direct. This object is a comet. It looks and behaves like a comet, and all evidence points towards it being a comet. Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, addressed the speculation about artificial origins. We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet. These aren't ambiguous statements or qualified assessments with uncertainty ranges. The trajectory is known, the object is natural, and there is no threat. Comparing 3I, Atlas, to the two previous interstellar objects we've detected helps put this encounter in perspective. 1I. Oumuamua arrived in October 2017 and sparked enormous public interest because of its unusual characteristics. Small, at perhaps 100 meters in its longest dimension, it appeared to be tumbling through space with an elongated shape. Most controversially, it displayed a slight acceleration that couldn't be explained by gravitational forces alone, leading some to suggest it might be an artificial object using some form of propulsion. The mainstream explanation for Oumuamua's anomalous acceleration points to outgassing, the same process we see in comets, but at a level too faint to detect directly. The object may have been releasing small amounts of gas that provided a gentle push, even though no coma was ever observed. But here's a detail often overlooked in discussions of Oumuamua. It passed much closer to Earth than 3I Atlas will. At its closest approach, Oumuamua was just 0.16 astronomical units from Earth, about 24 million kilometers. That's still 11 times farther than NASA's threshold for potentially hazardous objects, but it's dramatically closer than the 1.8 AU separation we'll see with 3I Atlas. If Oumuamua posed no threat at 0.16 AU 3I, Atlas certainly poses no threat at 1.8 AU 2I. Borisov arrived in August 2019, discovered by amateur astronomer Gennady Borisov, and became the first confirmed interstellar comet. Unlike Oumuamua, it displayed clear cometary activity with a visible coma and tail. Its closest approach to Earth was about 2 AU, comparable to 3I ATLAS, and its estimated diameter fell between 500 meters and 1 kilometer. 3I Atlas dwarfs both of its predecessors in several ways. It may be 10 to 100 times larger than Oumuamua if the upper size estimates prove accurate. Its hyperbolic excess velocity of 58 kilometers per second exceeds Oumuamua's 26 kilometers per second and Borisov's 32 kilometers per second. Its orbital eccentricity of 6.139 far surpasses Oumuamua's 1.2 or Borisov's 3.4. What this tells us is that 3I Atlas came from deeper in interstellar space, traveling faster and for longer than either previous visitor. Its extreme velocity and eccentricity suggest it was ejected from its home system with tremendous force, possibly during a close encounter with a massive planet, and has been traveling through the galaxy ever since. The estimated age of 7 to 14 billion years places its formation potentially in the earliest epochs of star formation in our galaxy. Our own Milky Way is estimated to be about 13.6 billion years old, which means 3I Atlas may have been wandering through galactic space for most of that time. The unprecedented coordination of observations deserves attention here, because 3I Atlas was discovered while still inbound. Unlike Oumuamua, which was already departing when detected, astronomers had time to mobilize resources. Over 20 NASA assets have participated in observations, including missions that were never designed for cometary science. The ESA's ExoMars Trace Gas Orbiter, orbiting Mars, provided critical tracking data during October 2025 when the comet passed near the red planet. This was particularly valuable because Earth-based observations were hampered during that period by solar conjunction, where the comet appeared close to the sun in our sky, making ground-based observations difficult. The view from Mars orbit had no such limitation. ESA reported that the Mars-based observations improved trajectory predictions tenfold. We now know exactly where this object is going, and that certainty is part of why the safety assessments are so definitive. NASA's Lucy spacecraft, currently en route to study Jupiter's Trojan asteroids, trained its instruments on the comet. The Psyche mission, traveling toward the metallic asteroid of the same name, did likewise. ESA's JUICE mission, on its way to the Jupiter system, contributed observations. Mars orbiters, including MRO, Mars Express, and TGO, all participated. The Hubble Space Telescope has made multiple observation passes, including a session on the 30th of November 2025, when the comet was 178 million miles from Earth. Additional James Webb Space Telescope observations are scheduled for December 2025. This coordinated campaign represents the most comprehensive study ever conducted of an interstellar object, and the results consistently confirm what the initial observations suggested. 3I Atlas is a natural comet displaying exactly the behavior we would expect from a volatile-rich body approaching a star for the first time in billions of years. Here's where we stand at the halfway point. The trajectory of 3I Atlas is precisely known. Perihelion occurred on the 29th of October 2025, with the comet passing 1.36 AU from the Sunday. Closest approach to Earth occurs on the 19th of December 2025. at a distance of 1.8 AU, which is 270 million kilometers and 36 times beyond the threshold defining potentially hazardous objects. NASA and ESA have issued unambiguous statements confirming there is no danger. Kelly Fast, NASA's acting planetary defense officer, confirmed the object was never considered an impact hazard, and ESA's Planetary Defense Office stated it poses no danger to Earth or any other planet. Compared to previous interstellar visitors, 3I Atlas is larger, faster, and on a more extreme trajectory. While Oumuamua passed closer to Earth at 0.16 AU, it was a small object showing no threat. 3I Atlas, despite being potentially much larger, passes 11 times farther from our planet. Over 20 NASA assets have participated in observations coordinated with ESA missions, including spacecraft at Mars, and the data consistently shows a natural comet with classical outgassing behavior. Now, we need to address the elephant in the room, the speculation about artificial origins and why the scientific community has firmly rejected it. July 2025 brought speculation from Harvard astrophysicist Avi Loeb, published shortly after the discovery announcement, suggesting 3I Atlas might not be entirely natural. His reasoning cited several characteristics he described as anomalies. The object's trajectory aligned with the ecliptic plane, its unusual chemical composition, the 16-hour brightness variations, and other properties. Loeb assigned what he called a 30 to 40% likelihood that 3I Atlas does not have a fully natural origin. This claim generated enormous media attention. Headlines about alien spacecraft proliferated, social media filled with speculation, and suddenly a fascinating scientific discovery became entangled with a very different narrative. Avi Loeb holds legitimate credentials as an astrophysicist. He has held prestigious positions at Harvard and has published extensively on topics including black holes, the early universe, and the search for extraterrestrial intelligence. His willingness to consider unconventional hypotheses has sometimes led to important discussions in the scientific community. But here's the thing. His claims about 3I Atlas have been firmly rejected by the broader astronomical community, and it's worth understanding why. Jason Wright, an astronomer at Penn State University, wrote an extensive rebuttal of Loeb's claims with a pointed assessment. Of Loeb's 10 anomalies, only 4 really have planetary scientists interested. None of them are evidence. It's a spacecraft. There's no reason spacecraft would do these things. There are lots of reasons comets from another solar system would. The characteristics Loeb cited as potential evidence of artificial origin, the brightness variations, the unusual composition, the trajectory, are exactly what astronomers would expect from an interstellar comet. These features don't suggest technology. They suggest a natural object formed in a different stellar environment. David Jewett, who led the Hubble observations of 3.1 Atlas, was even more direct in an interview with NPR. Honestly, I think it's a way to get attention, and it's very, very successful. I think it's an interesting object, but it's a comet. It's not an alien spaceship. The 16-hour brightness variations that spark so much speculation are caused by the rotation of an irregularly shaped nucleus with varying volatile content, which is standard cometary behavior. The unusual composition detected by JWST suggests the object formed far from its parent star, in conditions different from our own solar system, which is exactly what we'd expect from an interstellar visitor. The ecliptic aligned trajectory that Loeb highlighted has a simple explanation. Comets from other stellar systems can arrive from any direction. The alignment with our ecliptic doesn't require an artificial explanation. It's simply the particular path this object happens to follow. At NASA's November 2025 press briefing, the agency addressed this speculation directly, with Associate Administrator Nikki Fox stating, "We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet." And here's something worth noting. Loeb himself acknowledges the most likely outcome. In his own writings, he stated, "The most likely outcome will be that 3I Atlas is a completely natural interstellar object, probably a comet." When even the person proposing the artificial hypothesis acknowledges it's probably not correct, that tells you where the evidence actually points. Rejection of the artificial origin hypothesis doesn't diminish the scientific importance of 3I Atlas. If anything, it highlights what makes this object genuinely remarkable. We are studying material that may be 7 to 14 billion years old, analyzing the chemical fingerprints of a stellar nursery that existed before our sun was born, observing outgassing patterns that tell us about conditions in a planetary system we will never visit, the JWST spectroscopy revealing the unusual carbon dioxide dominance isn't evidence of technology. It's evidence of formation in a cold, distant region of another solar system, followed by billions of years of preservation in the deep freeze of interstellar space. That's scientifically extraordinary in its own right. The extreme velocity of 58 kilometers per second isn't a sign of alien propulsion. It's evidence of a dramatic ejection event, perhaps a close encounter with a giant planet that flung this object out of its home system with tremendous force. Understanding that process helps us understand how planetary systems evolve and how material is exchanged between stars. The size of 3I Atlas, potentially much larger than previous interstellar visitors, gives us the opportunity to study an object substantial enough to retain complex chemistry over cosmic timescales. This isn't just a pebble tumbling through space. It's a remnant of planet formation in another solar system, carrying information we could never obtain any other way. Tom Statler's observation bears repeating. 3I Atlas is not just a window into another solar system, it's a window into the deep past. That's the real story here. Not alien spacecraft, not existential threat, but the privilege of briefly glimpsing an object older than our own celestial neighborhood, carrying evidence of how stars and planets formed in the early universe. 3I Atlas is teaching us something about how common interstellar objects might be. Before 2017, we had never confirmed an interstellar visitor. Detecting Oumuamua came as a surprise. Detecting Borisov 2 years later suggested these objects might be more common than we thought. And now, with 3I Atlas appearing just 6 years after the first detection, astronomers are revising their estimates upward. The improving detection capabilities of survey telescopes like Atlas, the Zwicky Transient Facility, and eventually the Vera-C. Rubin Observatory suggests we may start detecting interstellar objects regularly. Each one offers a sample from a different stellar system, a chance to compare the chemistry and physics of planet formation across the galaxy. 3I Atlas, because it arrived at a time when our observation capabilities far exceed what was available for Oumuamua, and even Borisov is providing a template for how to study these visitors. The coordinated campaign involving space telescopes, ground observatories, and spacecraft throughout the solar system demonstrates what's possible when we have time to prepare. The comet will remain observable with small telescopes through spring 2026. After its March 2026 encounter with Jupiter, it will accelerate back toward interstellar space, eventually exiting our solar system permanently, and then eventually there will be another visitor and another after that. Each one a messenger from elsewhere, carrying information about the diversity of planetary systems throughout our galaxy. As of early December 2025, 3I, Atlas is approaching its closest distance to Earth. The Hubble Space Telescope reobserved the comet on the 30th of November 2025 at a distance of 178 million miles from Earth, and additional James Webb Space Telescope observations are scheduled for December 2025. Despite the speculation that has swirled online, and despite the clickbait headlines about alien threats, the scientific story remains clear and consistent. Every observation confirms what astronomers determined in the first days after discovery. 3I. Atlas is a natural interstellar comet displaying exactly the behavior we would expect from a volatile-rich body approaching a star for the first time in billions of years. The trajectory remains precisely as calculated. Closest approach to Earth will occur on the 19th of December 2025 at a distance of 1.8 astronomical units, or 270 million kilometers, far beyond any threshold of concern. The comet is moving outbound from the Sun now, heading toward a March 2026 encounter with Jupiter that will further accelerate it back toward interstellar space. After that encounter, 3I, Atlas, will leave our solar system forever, continuing into the vast darkness between stars, carrying with it whatever secrets it hasn't revealed during its brief passage through our neighborhood. Billions of years from now, it may pass through another stellar system where other observers, if they exist, will have their own fleeting opportunity to study this ancient traveler. The question we posed at the beginning of this journey has a definitive answer. Is 3I, Atlas, a threat to Earth? No. The answer is no. It has always been no, and the trajectory was certain from the first reliable observations. At closest approach, this interstellar comet will remain 270 million kilometers from our planet, nearly twice the distance from Earth to the Sun, 36 times beyond the threshold defining potentially hazardous objects, approximately 700 times the Earth-Moon distance. No mechanism exists by which this object could harm Earth. The calculations are precise, and the observations confirm the calculations. NASA, ESA, and every competent astronomical institution that has examined the data has reached the same conclusion. What 3I Atlas offers is not danger, but opportunity. The opportunity to study material from a stellar system potentially billions of years older than our own, to analyze chemistry that reveals conditions we could never otherwise observe, to glimpse the deep past of our galaxy frozen in ancient ice. Consider this as you settle into the quiet of the night. Right now, as you listen to this, an object that may predate our sun is passing through our solar system. Billions of years of travel across distances we can barely conceptualize brought it here, across the empty vastness between stars where temperatures hover just above absolute zero, and the nearest light sits impossibly far away. Within its ancient ice, it carries the chemical fingerprints of a stellar nursery that has long since dispersed, evidence of conditions that existed when the universe itself was young. And for this brief moment, brief on cosmic timescales, though it spans months of human attention, we have the privilege of studying it. Our telescopes, scattered across Earth and throughout the solar system, are gathering light that is reflected off this interstellar wanderer. Our spectrometers are parsing that light into its constituent wavelengths, revealing the molecules locked in ice for billions of years. Our computers are tracking its trajectory with precision measured in kilometers, confirming with each passing day that it poses no threat and offers only wonder. This is what science gives us. Not fear, but understanding. Not sensationalism, but the quiet accumulation of knowledge. Not the false excitement of alien threats, but the genuine excitement of contact with the deep past of our galaxy. 3I. Atlas is a messenger from elsewhere, and its message is simple. The universe is vast and old and full of wonders we are only beginning to detect. Other stellar systems have formed planets and comets and all the familiar structures we see around our own sun. Some of those systems are billions of years older than ours, and their remnants are still drifting through interstellar space, occasionally passing close enough to study. That's not a threat, that's a gift. If this journey through the science of 3I Atlas has been meaningful to you, I'd be grateful if you'd consider leaving a like or a comment. It helps this channel reach others who might find value in these quiet explorations of the cosmos. And if you're drifting towards sleep now, let me leave you with this image. Somewhere out there, beyond the orbit of Mars, an ancient comet is continuing its journey through our solar system. It has been traveling since before our sun existed, and it will continue traveling long after our sun has faded. For this brief moment, our paths have intersected, and we have had the privilege of glimpsing something truly ancient. Sleep well, and may your own journey through the cosmos, however brief, be filled with wonder.